say hi. Hi. Say hi again. Say hi. Hello. Hi, girls. Okay. Today we're gonna do a video lesson on sketching of graphs. We're gonna talk about how to sketch curves as of this nature. More importantly, curves of this nature. Okay. The graphs in the form of y equals a bracket x minus h bracket square plus k. This is for Terry. Okay. Today. Okay, let's start off with a very quick recap, okay, on how to sketch curves of this nature. I talked about that in the last session. Okay, so what we'll do now is this. We will take about 2 minutes. Okay, a very simple routine. I want you to take 2 minutes to pen down your thoughts of what you can remember from the previous lesson on how to sketch graphs of this nature. Okay, so what are the important things you must take note of? What is the how do I determine if this projected graph is a U-shaped smiley face or a sad face? Think about that. Okay, so I'll give you 2 minutes to pen down your thoughts. Then later I'll get one representative to come up here to tell us what she has done. Is that alright?
To determine if it's a happy face or a sad face graph, it's x squared. It's a happy face. Happy face. Then if it's a negative x squared, it will be a sad face.
Good. What else have you learned?
So when y equals to 0, x equals to negative 2 and x equals to negative 4.
Okay, what's the purpose of letting y equals to 0? What's the purpose? Is to find?
X-intercept.
So clever. Great. Okay, then?
First you have to draw a U first, a U shape, then you draw X-intercept.
Great.
Then the negative 2 will be here.
Very good. Must be on the left, right?
And 4 will be here.
Great.
Then you draw your Y-intercept from there. You'll be further away from 4. So
Very good. Very good.
Right. Then
Please state the origin. Put down the 0. Okay. Great.
must remember to have 0.
What Kai Xin has done is has shown us it's almost perfect. Almost perfect, right? She's able to tell us that this one is a quadratic graph. By looking at the coefficient of x squared, okay, she's able to determine whether is this a U-shaped graph or a set face graph. She's pointed out to us correctly. Okay, let me just build on what she has said. It is not just x squared, then it's happy face. Over here, we're looking at whether it's over here the coefficient x squared. In this case, is positive. Okay, not that it is 1 numbers. Please don't get it mixed up. If this is 2, this is 3/4, this is square root 5, doesn't matter. As long as the coefficient x squared is positive, we have a smiley face. Okay? And over here, when the coefficient of x squared is negative, is it negative 5, negative half? It doesn't matter. As long as it's a negative number, what we have is a sad face. So the process that she went through to sketch this graph is almost flawless. There's only one thing that is missing. Can you tell me what is it? It is? Very good, very good. To find the x-intercept, we let y equals to 0. So if you want to determine the y-intercept, we must let, everybody, it must let, very good, x equals to 0. So when you plug it in, x equals to 0, so we have minus 8, okay, negative 8. So this graph will be flawless. Okay, x-intercept is shown plus the y-intercept. In the previous lesson, we went on a little bit more, okay, on building on our knowledge of this kind of graph. What else can I add to it? I can add in the equation of line of symmetry. So if I ask the class, girls, can you tell me what is the equation of the line of symmetry for this graph that Kai Xin gave us? Everybody, it is? X equals to 1. Okay, how do you reach x equals to 1? How do you get that value? In the previous lesson, I shared this. The equation of line of symmetry, you know, of a quadratic graph always takes the form of x equals to a. Okay, but what is this a? It is actually the average of your x-intercepts. Okay, I say again, Josima is the average of your x-intercepts. Are we okay? So if you take 4 plus minus plus negative 2, we actually have 2. 2 divided by 2 is 1. That's why this is x equals to 1. That's the equation of the line of symmetry for this curve. Are we good with that? On top of this equation of this line of symmetry, we also learned that we can also determine the minimum value of this graph. Listen carefully, I said the minimum value of this graph. When I ask for the minimum value of the graph, am I looking for the x value or y value? Think first. Am I looking for the x value or the y value? Lauren, when I ask for the minimum value of the graph, am I looking for the x value or the y value? So smart. Okay, answer me please. Okay, very good. So when we ask for the value of the graph, please remember we are always looking for the y value. So over here, how do I determine what is the minimum value of this graph? All we have to do is substitute x equals to 1 into this equation. Is that okay? So when x equals to 1, we plug it inside. 1 plus 2 is 3. So 3 times minus 3 will be negative 9. So this is what happens when x equals to 1. Okay, when x equals to 1, y equals to negative 9. So that tells me the minimum value of this graph is minus 9. Everybody clear? If I were to move on, I ask you, what is the coordinates? What is the coordinates of the turning point of this graph? The coordinate will be 1, negative 9. Is that alright? Okay, that was what we did in the previous lesson. For today's lesson, I'm going to talk about graph that's of this nature. Okay, this graph, this quadratic graph, okay, is in the form of y equals to a bracket x minus h bracket squared plus k. So over here, based on what you have seen from my previous video, okay, the one that I did last year. So this A over here tells us a very important information. When A is positive, can you tell me, do we have a smiley face or a sad face? It must be everybody. It is a smiley face, right? Smiley face. This is a U-shaped graph. When A is negative, this one you will have a sad face graph. You notice this concept is exactly the same as what we have done over here. Exactly what as it told us. Nothing has changed. It is the same. Okay, what is the powerful thing of this particular format? If we make you sketch a graph that's in this particular format. For this version, right, the critical concept you get is the x-intercept. Where the graph looks like, how the graph looks like, and then plus the x-intercept. For this graph, right, you can't tell easily where the x-intercept. However, you can tell a very important information. For those who have watched my video, turn the camera to Beverly. Beverly, can you tell us? Okay, from the previous video, can you tell us what is this key thing that you can learn from this particular drawing graph that's of this nature? Very good. Okay, excellent. See, you get to learn that for this particular graph that's of this nature, you look out for the turning point of the graph. Is that okay? See, this version that Kai Xin showed us, you're able to tell the x-intercept easily. You are not able to tell the coordinate of the turning point that easy unless you find the line of symmetry and you find the minimum or maximum value of the graph. From there, you can deduce what's the coordinate of the turning point. For graphs of this nature, you can tell instantly what is the coordinate of the turning point. Okay? In this case, what's the coordinate of the turning point? It is HK. Okay, HK. This is the coordinate of the turning point of the graph. Are we good with this? Okay, over here what you see is an equation y equals to bracket x minus 2 bracket square plus k. Over here, if you look, this what I've written in blue actually is in this particular format, right? It's in the form of y equals to a bracket x minus h bracket square plus k. Can everybody tell me what is my a based on what I've written here in blue? A is, everybody, A is 1. Loud and clear, please. What is my h? 2. Is it 2 or minus 2? Look carefully. Is it 2 or minus 2? 2. Right? The h is 2. Look. X, minus, so h is 2. Last but not least, what is my k? My k is 5. So this tells me that my graph, my turning point is the point 25. So we know this graph is a smiley face that has a minimum point, the coordinate of minimum point is 25. Okay, how do we sketch that? Okay, can we take 1 minute to sketch this graph now? Please begin. Okay, so how does this graph look like? Okay, I believe all of you have Finish sketching your graph. Okay, so this is what Chirsty has. Thank you very much. Thanks Chirsty for showing us what she has done. Okay, remember in the classroom setting, we're all here to learn. There's no room for condemnation in this classroom. Okay, we're all here to learn. So please don't be afraid if you make mistakes. We all make mistakes, myself included. So we are all here to learn. So over here, this is a quadratic graph that Chirsty has done for us. So according to her understanding, this is how the graph of y equals to x minus 2 bracket square plus k looks like. Okay, one thing that I like, she's able to identify straight away, this is a U-shaped graph. Chirsty, how do you know this is a U-shaped graph? Because
The A is positive.
very good. A is positive, right? Over here, the A is 1, we know it's a smiley face graph. Okay, the next thing over here, I have to ask ourselves to check our own understanding. Over here, she has x equals to 2, and then she has a 5 over here. Okay, look, let's take a look at what we have. My dear, this is the y-axis, right? What is the equation of the y-axis? X equals to 0. So can x be 2 here? You know cannot be really, right? So this one cannot be. Second thing I want to ask you, you notice this is a 5, at this moment is a 5 here. This is a minimum point, am I correct? Okay. You notice your curve does not pass through the minimum point? That is the second area we're going to ask ourselves. Is that theoretically sound? Okay? So over here we know that this is not correct, right? We have to fine-tune our understanding. We have to fine-tune what we know. Okay, so let me help you now. Let me help you crystallize your understanding. We know it's a U-shaped graph, smiley face graph, that is what Chirsty has shown us. The minimum point is 2,5. Wait a minute, what did I say? Minimum point is 2,5. It means the lowest point on this graph, the smallest point, the coordinate is 2,5. Am I right? That means if I draw a smiley face, Chirsty, can you tell me, is this 2,5? 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 Yes, right? This must be 2,5. At this point, this must be 2,5. Because it is the lowest point, the minimum point of the graph. Am I correct? Thank you very much. Okay, Hannah asked a very important question just now. Must the minimum point cut the x-axis? I need you to visualize now in your mind. I have a point 2,5. So x coordinate is 2, y coordinate is 5. The minimum point of this graph, the minimum value of this graph is 5. My first question to you is, does this graph cut the x-axis? Everybody, loud and clear, does it cut the x-axis? No. Because the minimum value of the graph is 5, right? What is the equation of the x-axis? Tell me, what is the equation of the x-axis? That's correct. Y equals to 0, right? So y equals to 0 is this line. This must be the x-axis. Am I correct? So this is the line y equals to 0. The equation of the x-axis, this is the x-axis, my dear. This is the equation. The equation of the x-axis is y equals to 0. The minimum value of the graph is 5. That explains why this graph is always entirely above the x-axis. Okay? Sidetrack a little bit to amens, So if a graph is always entirely above x-axis, will it cut the x-axis? If it doesn't cut x-axis, will it have any x-intercept? No x-intercept, will it have any roots? So b squared minus 4ac is? Negative. Very good. Smaller than 0. Okay? So back to image now. Okay. So this is my minimum point. So now I have the x-axis. Let me put in the y-axis. I want you to ask everybody, is the y-axis here? Can the y-axis be here? No, because x equals 2 is here, right? So over here, this will be the y-axis. This is the y-axis. So the origin is here. Have I finished the graph, everybody? Have I finished the graph? No. One value is missing. What's the very important value? We must always state in all sketches. The y-intercept. The y-intercept. So how do we determine the y-intercept, somebody? How do we determine the y-intercept? When x equals to 0. So let's put x equals to 0 inside here. What do we have? 0 minus 2 is negative 2. Negative 2 squared is 4. 4 plus 5 is 9. So this is 9. We are done. Is that alright? Yeah, state the coordinate of the turning point, okay? Yeah, nice. state of origin. Origin. Very nice, Kerri. Good job. Very nice. Beautiful. Okay, thanks so much, Kerri, for working on this question on the board. Okay, this particular question says you're given an equation y equals x squared minus 8x plus 5. Can you express it in this particular format? Okay, over here, I like what Kerri has done. She approached this question using the completing the square method. Right? So over here, she recognized that her b was negative 8. That's why when she introduced the term b over 2 bracket square, look, this is beautiful. Negative 8 over 2, negative 8 over 2. Okay, and then based on what she has learned from previous lesson, which I've shared with you, these three terms will be collapsed into one perfect square. In this case is x minus 4 bracket square. This is actually negative 4, square will be positive 16. Positive 16 times negative will actually give you negative 16. Negative 16 plus 5 is negative 11. This is beautiful, okay? This is the way we do this type of question using the completing the square approach. But what if some of you say, Mr. I'm not very familiar with completing the square approach. I'm quite weak at it. Is there another way of doing this question? Answer is yes. It's called a comparison method. Okay, please pay attention. I'm going to demonstrate to you now. You see, you're given that y equals x squared minus 8x plus 5. You're also given that y is equal to x minus p bracket square plus q. Watch what happens now if I expand out what I have in blue. Okay? So this will be x minus p plus q. I expand this out. Y is equal to x squared minus 2px plus p squared plus q. This is y. My dear, this is also y. Am I right? Okay, watch now. If I put them side by side. This is y equals x squared minus 8x plus 5. This is y, this is also y. No, this is x squared, this is x squared. So what does that tell you? It tells you that, look at the coefficient of x. What's the coefficient of x, girls? It is negative 8 or positive 8? Negative 8. It tells you that negative 8 must be equals to negative 2p. Okay? Are we cool with that? So this tells you that p must be 4. Is this easy? Can we do this? Okay, this is called a comparison approach. Let me share with you. Watch it carefully. Look at the constant term. The term that is independent of x. The term that is independent of x. Okay? So in this case, the constant term here is 5. So if you look over here, what is my constant term? Do you notice there's a term that's independent of x? So this tells me that p squared plus q must be equal to 5. P is equal to 4, right? So from above, P is 4. 4 squared plus Q. So 5 is equal to 16 plus Q. Q is equal to 5 minus 16 equals to negative 11. So that tells me P is 4. Q is negative 11. So if I plug it back in here, what do I have? I'll have y equals to x minus P is 4. Q is negative 11. Ta-da! This is called a comparison approach. This approach basically uses your expansion. And then after you expand, you compare them. Coefficient of x squared with coefficient of x squared. Coefficient of x with coefficient of x. Constant term with the constant term. And then we get P and Q. Everybody doing okay? Do you understand what I'm doing? Over here, right? So we have already established that P is 4, Q is negative 11. So this tells me that HK is my turning point. From here, I know that HK is my turning point. So H is 4, K is negative 11. So this is 4, this is negative 11. So this is my turning point. Let's take a look at the coefficient of x. What is the value of A? The value of A is 1. That tells me this is a smiley face. The minimum point is 4, negative 11. So 4, negative 11 over here. Okay? So look at this graph. Smiley face, minimum point 4, negative 11. X in the line of symmetry, we x equals to 4. Okay, the minimum value of the graph is negative 11, so the coordinates of the turning point is 4, negative 11. Okay, thanks, Chirsty. Is this graph flawless? It's almost perfect, but is it flawless? No, right? For all sketches of graph, we must always include what? Y-intercept whenever possible, especially for quadratic graph. Over here, what is the Y-intercept? Can somebody help me? How do you find the value of the Y-intercept? Come on, let's take a look. When x equals to 0, 0 minus 0 is 0. 0 plus 5 is 5. So what's the Y-intercept of this graph? It must be 5. So in this case over here, this graph, then I'll say that the graph is not extremely accurate because you're cutting it. The Y-intercept is cutting over here. So that's not very wise. But your graph is almost flawless, almost correct. So all you have to do is just do a little adjustment. Okay? Just a little tiny adjustment. So over here, you can just draw this to the Y-intercept, cut that. Beautiful. Okay, this so the origin is over here. I hope I'm very clear with what I'm sharing with you. So when you sketch a graph, please take note. When you sketch a graph of this nature, turning point has to be indicated clearly. Y-intercept, please state it also. Okay? And then the graph XY axis must be labeled with the origin. Okay, line of symmetry is always your x equals to h. This is why this is important. X equals to h will always be your line of symmetry. Okay, will always be the equation of the line of symmetry. Okay?
We did it! We did it! We did it! Yay! Always team up. We did it! We did it! We did it!